Okay, let's start. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everybody. Thank you for coming. On behalf of the chairman of the department, I would like to welcome you all. Thanks to Dr. Isam, to Dr. Badri for accepting the invitation and for accepting to share with us the aims and objectives of the center, the kind of mathematics used in their center, and what is expected from mathematicians in case they join the center. You will have whatever time you need for a presentation, or two presentations actually, and it will be followed by a discussion. Please, the floor is yours. Please go ahead.
Again. طيب بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيد المرسلين وعلى آله وصحبه أجمعين. Thank you, Doctor, for giving us the opportunity to talk to our colleagues. My name is Asam Al-Jundi. I'm the director of the IRC for membranes and water security. Today I'm going to present the aims and the programs of our center. Can you hear me clearly, Doctor?
Yeah, we do. We can hear you clearly. Yes, we do.
I'm going to talk about the mission of the center to pursue solutions for local and global challenges. And those are basically the industrial challenges that is related to water and membrane industries, and to commercialize research output of sustainable and innovative solution through the Dhahran Techno Valley, and to provide students and researchers with superior educational and research experience. And we just started this by taking some of the what is called summer research experience for undergraduate students. We have 4 students right now. They are getting their research experience in our center. In our center, we have 4 focus areas, or 4 programs, you might call it: water security, water treatment, desalination, and membrane technology. Water security, Dr. Badri will talk about it, maybe, but I can briefly summarize some of the topics that we are interested in, such as safe drinking water and conservation strategy, water-related natural hazards and risk management, water quality monitoring, ecosystem management, water resources development, planning, management, and conservation, climate change and water scarcity, groundwater resources, system modeling, groundwater contamination, water law and regulations, urban hydrology, applications of remote sensing. Obviously, those kind of topics may be related to the hydrologists, environmental people, but it contains some modeling that Dr. Badri will talk about. The water treatment program, we are focusing on produced water treatment. This water comes out from the oil and gas industry with huge amounts. You can imagine, with each barrel of oil, on average here in Saudi Arabia, 3 barrels of oily water comes with it. So if the production is 10 million barrels, 30 million barrels of contaminated water comes with it. And this needs to be, treated and get rid of sometimes by re-injecting to the groundwater, to the well. So this is one of the grand challenges that we have. Brine mining from desalination plants, in which valuable minerals comes out with it, and it is dumped back to the sea. Microplastics and heavy metal removal from various industries. Industrial water treatment. Each industry has its own water that needs to be treated with different characteristics. Water disinfection, wastewater treatment, water pollution and control. Those are the main topics underneath this water treatment program. The third program is about desalination. In desalination, we are interested in two types. Broadly speaking, one is the membrane-based desalination, such as the reverse osmosis, electrodialysis, forward osmosis, membrane distillation, pervaporation, etc. And the thermal-based desalination, which is the dominant technology here in Saudi Arabia, such as multiple effect evaporation, multi-stage flash, and multi-effect distillation. However, we are also interested in other technologies, such as the capacitive deionization desalination, or even the integrated and hybrid processes in which it will combine different technologies, along with maybe electricity production. In addition, we are also interested in solar desalination, but not in the solar side. We are interested in the desalination side that can be driven by solar energy. I can say that our center has its the thrust is in this program and the center. And the fourth and final program is the membrane technology, in which any process that has membranes, it's basically of our interest. But we are focusing currently on the organic solvent reverse osmosis and nanofiltration processes. This process can eventually replace some of the most expensive processes in the market for purifying organic solvents. Chemists, chemical engineers, and they spend their life separating molecules from each other. And the most significant are the organic solvent, and now it is currently separated using distillation, which is an energy-intensive process. So we're trying to replace this technology using the membrane technology. In addition to the gas separation, this is also an industrial or an important process in the industry, in which using the membrane technology, it can save a lot of money, in addition to the smaller footprint and the retrofitting easiness to the any process. Dehydration of organics and acids, fuel cells, membrane reactors, crystallizers, and condensers. So basically any technology that involves membrane, we are interested in. Those are the main four programs that we are pursuing currently and the center. Maybe the thrust is in one area, but we are expecting, with the help of our affiliates from different departments, to gain momentum and other programs. Challenges, grand challenges, groundwater depletion, fouling resistance membrane, organic solvent membrane, produced water, brine mining, and scaling up. Maybe for the math and statistics department, we're not interested in solving this problem, rather to find the avenue where you can fit your knowledge inside the center, and which I will try to tackle in the next couple of slides. The targeted sectors for our center: desalination plants, energy, agriculture, mining, wastewater treatment, and environment. And before going to where I see a mathematician or a statistic faculty can fit in, let me just touch down with one slide on membranes, because most of our work, except on the water security, is focused on membranes. Membranes, as you can see right here, this solid blue semi-permeable material. Usually it is a solid material, but this material has the characteristic to selectively permeate a certain compound, such as this one, over the other one. So here is the feed from the left-hand side. You will see, for example, 50-50 mixture, but the permeate from the other side is way beyond 50-50. Maybe it is 90 to 1% to 10%. So this membrane is basically a semi-permeable. It will permeate one component selectively over the other. These membranes can be classified into broadly two types: dense membrane, solid ones like this one, or porous one like this one. It has pores. So the mechanism of separation is basically size exclusion. Right here, larger size will not go through, while smaller size will go through the membrane. This is in the very, very basic definition of the membrane. It is a semi-permeable membrane. Now, the mechanisms of exclusion, it could be steric, electrostatic, dielectric, van der Waals forces, frictional, or viscous forces. And these mechanisms has models. Most of it, I believe, it is empirical models. That is based on, collecting large volume of data and then statistically try to fit it into a certain function. So what do we need? Basically, our ultimate objective in our research is to bring a membrane that works for the industry. It can separate molecules from each other, separate hydrogen, separate carbon dioxide, separate water from salt, such as the reverse osmosis membrane, in which we use for desalination, for the desalination of water. So the ultimate goal is to bring a membrane that works for a certain industry. This is our ultimate goal. Now, along the way, there are some models that can be used to predict the behavior of such membrane. This is not our focus. This is, I can say, none of the research scientists in the center that I am aware of has ever published something in modeling and simulation of membranes. So maybe this is one of the avenues that I see mathematicians get into, is the modeling and simulation. We are lacking dependable and accurate models that describe the relationship between the structural properties of the membrane and the separation efficiency. Molecular simulation and the interaction between the molecules and how do they interact with the surface of this membrane. Flow dynamics inside different membrane modules, whether it is a flat sheet, hollow fibers, spiral wounds. It has many geometries. So we need to see the flow dynamics inside these modules. Modeling of transport mechanisms. As I said, we have different mechanisms, and those mechanisms basically are modeled using empirical equations. So we need something more dependable than those equations. I'll give you two examples of the modeling and simulation in this area. I picked this one, a universal transport model for reverse osmosis system. Reverse osmosis is the technology that we use, the commonly used technology for desalination. It's a membrane-based technology. It starts with this kind of equations. To come up with such an equation, you have to understand the fundamentals of the reverse osmosis itself. And then you can build your model based on your understanding and the simplifying assumption. And usually they will throw in different adjustable parameters that I don't like to fit the experimental data to the model and show that the model is working fine. So this is one example. A second example is for the fuel cell, the proton exchange fuel cell. Start with mass balance and then momentum balance, and maybe later they will use energy balance if applicable. I don't know. I'm not experienced with the modeling of fuel cells, but this this kind of equations that you may see in such modeling. This is one avenue that I can see where the Department of Mathematics and Statistics can get into collaboration with the IRC of membranes and water security. Basically, those are the two examples that I brought. Dr. Badri will take over and he will present more examples on the water security side. And with this, I finish my presentation. Thank you for listening. I'm not sure if you want to allow for questions right now or at the end of the second presentation.
Thank you very much. Thank you very much. It's up to you.
Yeah, if there is any question, I can take it now.
Any questions from our faculty? Okay, let's go to the second presentation and hopefully. Okay, please go ahead, Dr. Badri.
Assalamu alaikum wa rahmatullah. Thank you very much, Chairman, and thank you very much, our Director. And assalamu alaikum to everybody. So I am Dr. Bedri Kurtuluş. I am considered as water resource engineer and as a hydrogeologist. So today, what I did I prepared one presentation that try to try to define some collaboration topics with mathematics and statistics department. So I will go first a little bit specific, and then I will diversify the topics. So generally, what we are working in hydrogeology, of course, we would like to understand. Our main goal is to understand the path of the pathways of the groundwater. So, however, of course, what we need, because we have a after getting lots of information from the field side, for the water planners, we really need to make an analysis of these system. We need to construct this system. So that's why I started with an idea that if it is possible, perhaps to conduct a common research, to have a big data analysis, to create a big data analysis things, to analyze the and hydrological balance, hydrogeological problems, and so on. What I said here, our main objectives could be to create some decision support systems, and to analyze this data analytics. For what? For it could be some specific problems. For example, here the water stress topics and intense drought, and also floodings are the main problems of Saudi Arabia. So using this decision support systems and prediction systems, if we could create together, we can come up with some solutions. And also, I believe some stakeholders, some governmental agencies could be interested for these kind of problems that we could solve. So as I said, perhaps you know these systems, decision support systems, that could be defined in different kind of methods. That, as I said, these kind of results: real-time drought monitoring, comprehensive analysis of past drought, and assessment of water stress risk. We can use this system to solve this kind of problems. So I would like to just mention here also why it is important to work on this kind of topics, because according to the Vision 2013, I found some of the phrases in the vision that really until 2013, the vision of the Saudi Arabia, especially for the managing of the water resources, it gives a very importance. And also in the vision, they want to renovate the data collection, data management, and also the way that the way to the mapping and the modeling. It gives a very importance in the vision. And also for the short and long term, the water resource monitoring and managing of all these data, it is very important for the vision of Saudi Arabia. So here it is just now I would like to here show you a snapshot of what could be some of the works that we can do it together, that now I am working on these kind of topics also. So as I said, the first one is the data assimilation techniques. So what we are doing, we have some data coming from the field, such as rainfall, evaporation, evapotranspiration, these kind of things. We are trying to understand the runoff prediction, or some flooding prediction, using some statistical analysis, such as it could be, they are calling soft computing techniques. one of them that I published in 2007. Now there are too many published in this kind of systems. However, this kind of systems is very well developed. So neural network can be used, physiologic or some combined methods that we can use to predict these kind of systems for different kind of environment. So if you have a historical data, if you have a reliable historical data, so what as a hydrologist, we are trying to predict this, for example, a runoff using this kind of systems. Another topics that it could be interested, this is the pipe flow modeling. So in this kind of pipe flow modeling, pressure loss or water loss calculations, why we are interested? Because in the water optimization report that we are writing, for example, in the environmental impact assessment reports, so especially in the offshore, there are big pipelines, and these pipelines are really important to estimate what are the pressure loss in the pipes. And also, we are now doing another project with SIO, Saudi Irrigation Organization, in Al Hassa, and they want to know the water pressure because they have a distribution system that they are using, the SCADA, and the water pressure is very important for the irrigation, to define the irrigation scheduling. So we are also interested to develop these kind of codes that I am developing in MATLAB. I know that there are some codes that it's written in a professional way. However, for our homemade code, I think we can also develop this pipe flow modeling topics. Another one that I am also, we are also, it could be interested. This is the oil spill dispersion modeling in 2 dimension. So it could be also an idea, which is very hot topics that in the Red Sea or in the Arabian Gulf that we could develop together, I believe. So here is my email. Here is my email. You can always call me, or you can always contact me with my phone that we can develop together. If you have any questions, I will be more than happy. Thank you very much, Chairman. Thank you very much, Director.
Thank you very much, Dr. Badri. The floor is open to questions. Any question, Dr. Yaz? Dr. Nasser? Statisticians, we have statisticians, we have people who have worked on porous media. By the way, what is the kind of equation you showed us, Dr. Isam? Is it a diffusion equation? It's a very complicated one.
It is based on the theory of solution diffusion, yes.
Yeah. Diffusion in porous media, right?
No, it's called solution diffusion. This is not a porous media, it is a dense media. It's the membrane for reverse osmosis is dense, it's not porous.
Okay, dense. Let's go to Dr. Karim, go ahead.
Yes, please. Thanks for the presentation, both of you. That's an excellent presentation. I have a very quick question. Is there a researcher in your center working in wastewater treatment?
What is it? Say it again, please.
Wastewater treatment. Is there anyone working in this area?
Yeah, of course. A lot of people work on wastewater treatment. Yes.
Okay. Could you please elaborate on this topic? How would you solve, or what techniques do you use mainly to apply or to resolve this difficulty? Does it what kind of mathematics?
Mathematics, as I told you, most of the people are not into mathematics. What we do in the wastewater treatment, we are using different technologies to remove the pollutants. For example, you have the stream of oily water or produced water. We are interested in technology that removes the oil from water, such as the adsorption, membrane technology, bioreactors, membrane reactors, any technology that can remove this oil. But on the mathematics side, maybe we can touch down on it. Some people touch down on it using very simple algebraic equation. That's it. That doesn't need a mathematician or anything. Just to describe the flow using the, as I said, algebraic equation and the driving force for the pressure-driven process, for example. As simple as J equals a constant multiplied by delta P, something like this. So not into mathematics. This is real basic. So our interest in water treatment is the technology itself, not the mathematics. What technology we are using? Different technologies, adsorption, extraction, membranes, you name it.
Okay, I was raising this question because there is a very interesting ongoing research at the moment with a few papers already published in this direction that actually uses chemostat models. I'm not sure if this kind of bioreactor.
Yes, yes. I worked on it.
In which you can use like excellent. They actually are trying to use periodic control for the biological water decontamination, trying to minimize the average output concentration of the pollution under a certain constraint. This is a kind of an optimal control model. I'm already preparing a project in this area. So it would be fantastic if there is anyone very interested or very closely related in the research area to speak at the moment.
Oh yeah, I formulated a group of 3 people who works on the bioreactors, and I can hook you up with them. We already will start one common project, and if you have something written, we can discuss it, and we can maybe start another project, inshallah.
Sure. Thank you.
Thanks, Dr. Aysam. Thanks, Dr. Karim. Dr. Nasser?
Yes, thank you very much, Dr. Tata, Dr. Sam, and Dr. Badri for this presentation. My question is to Dr. Sam about some of the consequences of possibly joining the research center. Of course, the objective of the research center is to go one step further from the publication and application. But still, publication is one of the side objectives. So my question is, when we come to the stage of the publication, who gets to decide the journal where you publish? Who gets to decide the author's order? Who pays the publication fee? Is it sponsored by the institute? And what are the consequences after the collaborative research is done?
It's like any academic collaboration. It doesn't matter if you have done it in our center or in your department. The way you organize the authors is the same as you do when you collaborate with your colleagues in your department. It is the same. Nobody gets involved in where you want to publish your paper. This is up to you. You want to go for Nature or Q4, that's up to you. We hope that you can and we can publish in Nature. We always shoot for the best, but nobody discusses such thing. Publication fees, did you ask about the publication fees?
Yes, one of the questions was, is the institute going to sponsor the publication fee?
Well, to be honest with you, I don't know. Because right now we have a system in which each faculty member can publish and can be funded for one publication in open access journals. I'm not sure about the projects that will be funded from the center. I will ask for it and I can get back to you.
Yeah, and my second question is about the contract we are going to sign with the research center. Will it be annual contract or biannual, or what type of contract will it be? And later, for example, if I get to know that I signed with this institute and I was better aligned with another institute, am I allowed to drop this one and get aligned with another institute, or what will be the procedure after signing with the institute?
I think it is a 2-year contract. If you find yourself better performing in another center, there is an option for a guest affiliate. You can be a guest affiliate over there. However, to drop from one research center and going to another, well, we never discussed this thing in our meetings. So I don't have no answer on this.
All right, thank you very much.
Thank you.
Dr. Aysam, go ahead.
Assalamu alaikum, everybody. Thank you very much for the nice presentations. I would like to ask about what kind of statistical analysis you used in your published paper, Dr. Badri. Just to have a brief idea about what type of statistical analysis.
In fact, we are working on the spectral cross correlation, these kind of simple geostatistical analysis, and also what we did we developed some codes that could predict in terms of the prediction, interpolation techniques. These are the techniques that we use it. So what kind else in terms of the statistics? I think these are that we are using. We can always I can send you our published papers, that if you are interested to look at it in more details.
Yes, if you please.
For sure. If you can send me your emails, I will send you.
Okay.
Thank you very much.
Okay, thank you.
If I may also add, sometimes when we design our experiments in any field, water treatment, desalination, and there are multiple parameters that we want to study, we usually use the design of experiment. And this design of experiment, we use a software, basically. One of them is the design expert. This design expert, you just plug in the independent variables and the responses, which is the dependent variable, and it will do all the statistics in the world. And we'll come up with, the 3D graphs and, ANOVA test and all the statistics that you can think of can be done using this simple program.
Maybe if we meet, maybe we can show me this software. I have no idea about it, or this package.
Oh yeah.
Because statisticians, we use other softwares.
Yes. This design expert is one of them. Minitab is another one. I use both. You can do all the statistics using this software. I will get back to you with it.
Thank you very much. Thank you.
Dr. Khalid.
Okay. Assalamu alaikum. Thank you, Dr. Aysam and Dr. Badri, for sharing with us research and scope of research in your center. I was looking at the slide by Dr. Aysam about, he put the title, "What do we need?" And you put there listed a number of issues that ring bells to many mathematicians. But those are kind of models or tools. But first of all, I would like to know for the center right now, what is the, eventually main objective? Is it to develop technologies or design of certain setups for efficiency and so on, or to solve problems, existing problems in the country, like as mentioned, flooding problems, contaminant flow problems, waste problems, etc. So what is actually the aim or the big picture of the center here?
It is to solve the local and global problems. Actually, the local problems are not much different than the global problems. When you talk about for example, the produced water here in Saudi Arabia, as I said, the average is 3 barrels of produced water per 1 barrel of oil, while in Texas it is 7 barrels of produced water per barrel of water. It is the same problem, but with larger scale in other countries, or smaller scale. So it is not much different. So we're pursuing solutions to these kind of problems by developing, in my side, if I want to talk about membranes, by developing membranes. The process itself, yes, it is another avenue, because the process is different than the membrane. The membrane is a small part of a big process. And in this regard, we have also other affiliates from chemical engineering department and other departments who will use simulation software using the data from the membrane itself. We just give him the data for the membrane, and he will organize the other unit operation that will constitute the process itself.
Okay, so if you take this as an example, so designing a membrane, you have data now, you can, even you have it experimentally, you can get the empirically whatever parameters needed there, and maybe do some simulations. But where is the room of modeling here? How modeling can be integrated into this process that eventually will make a difference in the design and prediction?
Yeah, modeling here now, as I said in the presentation, you can go on different levels. For example, the molecular simulation. Molecular simulation, you will try to find the interaction between the molecules that you want to separate with the membrane itself. You can model the flux, how the flow will go from one side to another side, to the other side of the membrane. All of this is needed, and it is, as I said, based on empiricism in many cases. Rarely you can see rigorous models for this.
But there are, working, let's say, ready-made simulators for these processes, like molecular simulation and so on.
You said, I'm sorry, I didn't get your question.
For molecular simulation and so on, I know colleagues, for example, in chemical engineering and so on, they have well-established, let's say, softwares or packages that simulate all of these dynamics, etc., etc. So exactly we can identify. I'm not criticizing, but I'm trying to get. I'm thinking loudly with you where one can make a contribution, really.
Well, I think the big contribution is to bring about an accurate model. All of these models, as I said, it has sometimes my professor used to call it a fudge factor. Fudge factor, meaningless factor, has no physical meaning or factors. Actually, some of the equations that I have seen, such as the Webb-Benedict-Robin equation, has 14 factors. 14 factors, adjust the 14 factors, and then you will end up with a straight line that passes, through all the data points. But those factors does not mean anything physically. So as I said, if you can get a model theoretical model without those factors, or with a meaning, something that has a meaning, that would be great. Still, the models that we use, it has, way large errors in most of the cases, large errors.
Thank you, Dr. Hassan.
Thank you.
Dr. Muhammad Riyaz.
Yeah, assalamu alaikum, everyone. Thank you very much for the nice presentation. Yeah, my question relates to regarding the students, basically. In our courses, I am from statistics background. So usually in our courses, we expect from the students to work on some real data sets in their projects. Can we involve the students, particularly in this recent era when we are offering some courses under this new approach of IBL in inquiry-based learning, where we have a lot of weight on project in a course, where we encourage the students to work on some real problems. For that, in our statistics courses particularly, we encourage the students to get access to some real data sets. Now, if, for example, in this summer and also in the coming term, I'm planning some courses under this approach, where I encourage the students to be involved in some project which has something to do with the real data set. So my question relates to, can we give, I've encouraged the students to reach to your research center for some real data sets. Is there any arrangement where you can accommodate the students for some real data sets?
Real data for what?
For example, because this is research institute related to working on different projects, right?
Yes.
Where you talk about some real topics where any kind of data set which relates to any real problem. Because
my brother, maybe my understanding of statistics is not much, but if you are looking for a large set of data in which we replicate the measurements 10 or 20 times, in my side, it's not available, I guess. I don't know if Dr. Badri has something like this.
For our site, in fact, for students, I can provide some data sets that it was collected from the field. It is not a problem. Just we need to think about the problem and what kind of data tests and what kind of statistical analysis you would like to do. So I can arrange for the students, no problem. However, of course, for each year to have a renew this data, this will be a question. However, for a couple of times, for sure, I can provide you some of the data for the different countries, not especially in Saudi Arabia, because to have a continuous data in Saudi Arabia, honestly, I am new. It is not an easy thing. However, for other countries, for sure, if you would like, I can provide you data.
Okay, thank you. Moreover, regarding the type of data or other things, for example, Dr. Isam was mentioning about the design of experiment. We offer a course at graduate level, a course which is mainly offered to these chemical engineering students who are doing their MS or PhD. And usually what we do in that course, we have a heavy load on the project where the students, by learning the techniques, we teach them in design of experiment, and then at the end of the course or during the semester, we expect them to keep looking for some real problem on which what we are learning in design of experiment under single factor or the factorial experiments. At the end of the day, we expect to write a formal report where they apply whatever they learned in the course on some real data set. So what I was thinking, why not to encourage them to get involved in these types of studies which your research center is carrying out, to get into these projects and do something which is directly beneficial for the department and the research institute itself.
Great. Thank you very much for this idea. This is brilliant. Yes, thank you very much.
And by the way, this every year we offer this course to a group of almost 20 students, and usually we make a group of 5 students. So that means every year almost 5 4 to 5 groups are working on these types of problems. So why not to bridge something like this where the students can be benefited and at the same time department and the research institute as well.
Excellent, excellent. Yes, just share my email with them and I will take care of it.
All right, inshallah. Thank you very much. Thank you.
Any other question, guys? Any other questions? Okay, perhaps one last question to Dr. Badri. Could you please elaborate a little bit more on the type of neural networks you are using or you have used? Are they deterministic? Are they continuous or discrete?
In fact, what we are doing, it is the time series prediction we are using. And these kind of neural networks, it is as I said, used for feed forward neural network, recurrent type. So different types that we use it to predict the real measurement, in fact, for the future cases. For example, flooding, it could be, especially we are interested more runoff, which is the discharge of the system for us. However, until now, for example, it is not well done. The turbidity, these kind of parameters can be worked on to which kind of, for example, neural network could be predict on that kind of parameters. It is not well done. So these kind of things we can work, inshallah, together. Also, if you have interested, doctor.
Yeah, how familiar are you, for instance, with let's say Hopfield neural network?
I am not too much familiar with the Hopfield. However, I know these kind of things. It is as far as I remember, these are learning again. However, it is not prediction. Hopfield neural network. I can be wrong. Is it prediction also used?
You feed with data and you get predictions. You get the output.
Okay. So it could be tested for sure. Yeah, it could be tested.
Kohn, Grossberg, bidirectional associative memory.
For sure.
Memoristic neural networks, things like that.
Yes, for sure. I can send you also a couple of my publication if you will be interested. We will be more than interested also. That we have in fact, we have for different types of data also that we can apply to these techniques.
Yeah, we are especially interested in systems of differential equations.
Okay, systems.
Not discrete, not tables and not discrete, but of differential equations where we can prove well-posedness, continuous dependence, stability. Okay. The main thing is stability of the system, reliability, robustness, and so on.
Robustness of the system.
Yeah.
I see that.
Okay. Thank you very much. Any other question? I think we should. No more questions. So thank you again, Dr. Isam Jundi. Thank you very much, Dr. Badri.
Shukran.
Questions were very informative, very well explained, very detailed. Everything is clear, but there remain some details here and there. We can. I'm expecting some contacts with the particular faculty individually. And we might have a second round, another meeting, perhaps in the reporting period or after that, depending on the needs, inshallah.
Inshallah. Thank you very much, doctor. Thank you,
Dr.
It's very nice of you. You can send us some publications with where we can find mathematics.
And some membranes.
Inshallah.
Yeah, really, it's. I mean, I'm Hassan Atasi. I'm the chair of the department. Really, we thank Dr. Isam and his group for this opportunity and answering our request to see them. I'm sure this will be a good start. I mean, so that we have good intersectional interaction between the department and your center. Wish you all the best. Thank you again. Thank you, Dr. Nasser, for arranging that.
Thank you, Dr. Hussein. Thank you, Dr. Hussein. Thank you very much. Okay, we keep in touch. Thank you very much.
Assalamu alaikum wa rahmatullah. See you.
Have a good day. Have a good day.